deployed. And starting, it is not only the classically synchronous based, your wind turbine generation based and lot of inverter based also the generation that is being deployed there, and the normal swing equation based just an analysis for the introspecting the coherency of the integrated system may not be a feasible solution. Similarly, the fault detection in a power network, it is well documented in the literature. However, the simultaneous fault, this implies one fault is not getting cleared, another fault further aggravates in the system. That means at the particular instant of time, there are two types of fault, that is evolving fault. In a practical scenario also it may occur. That means you have the line to ground as well as the line to line fault occurring in the same in a particular time instant, the time span being considered, so that how to address the particular challenge. Similarly, the distribution network. The distribution network, on contrary to the transmission network, it is in fact it is not only complicated due to the existence of the lot of nodes, the inherent power flow analysis for a active distribution network, and the inherent stochastic and intermittent source being deployed, different control scheme being addressed due to the different cluster of microgrid being deployed at a strategic bus. So there itself, your distribution system, the monitoring, the protection aspect, and the control issues also is different than that of the transmission network, and thanks also taking without sacrificing the cost, to get the accuracy of the system should be also taken neck to neck, how to introspect the behavioral system of the distribution network. The event detection, that means starting from your capacitor switching, your sudden rejection and addition of the loads, your different type of events, power quality events, how that is accomplished by virtue of this micro PMU. And it is a multi-agent based, because sometimes you talk about the different type of control, and basically due to this inherent intermittent source being deployed starting from wind and solar, your robust control is an elegant choice, but it is not adequate enough to address the control issues. So in that context, how the consensus is being achieved by exchanging the information between the two agents, and totally the error, how you get a consensus error, and in the surface how to design the same to get a desirable control effect. So this is a very basic thing. I don't want to discuss this interconnected system as far as your rotor angle stability and your transmission line protection being concerned. But however, now when the PMU is deployed now, you are already well aware of the different blackouts. Just recently, 2012, after the 2012 blackout, the Mumbai blackout also, just before a couple of months, it happened. So now the question is that the PMU, as far as the observability of the grid is concerned, it is fine. But is it feasible to deploy at all the locations, or you have to go for the optimal location for the same? So for the optimal locations, you have to eliminate the redundant features. You have to get the exchange of the information between the adjacent PMU, the losses to be minimal, and the different channel capacity, the transmission rate, all factor taking into the consideration. You have to formulate the desirable objective function, taking the cost factor into the account, and you have deployed the PMU at the strategic location in order to have the observability of the grid. So now when you go for these swarms, as far as the total analysis of the total power network being concerned, it is the power network is not only due to the normal segregated components starting from the generator, transformer, and the transmission line, or with all the rigorous modeling being constant with the exact modeling, frequency dependent modeling. And in order to introspect the dynamicity of the total system in presence of SDTC and facts, there the further how the PMU plays an important role to get the total introspection of the grid. That is the point of interest. So this how PMU looks like. You also know as far as the thing is concerned. Now the question is that synchronized measurement. People used to tell the synchronized measurement from the PMU is possible. How does it really works, and what is the philosophy behind that? That is very important. The synchronized measurement, that means when you are talking, you have the different segregated component in the integrated power network, and the modeling aspects taking all the nonlinearity, the saturations, the exact model, or the primitive network model being taken into the consideration. You have already taken into the that you have included the same. You have brought the higher differential equation and subjected to certain constraints starting from the generation ramp rate, your transmission system thermal limit, and your other constraints, your tie line exchange with the interchange, schedule interchange power. So that is okay. But the question is that with how the synchronized measurement, that means when you are taking the two instant at the particular instant, the retrieval of the data at a two strategic location, if it is coming simultaneously or with a minimum latency which is tolerable, because ultimately you have to get a feasible solution. And for that, if you have a asynchronous data from the two ends, then your total objective get defeated for the same. So the synchronized measurement and how much latency is tolerated with respect to suppose you stand in a faster time scale, the latency is not tolerated. That means in the protection domain. Then you go for the your total your stability with some millisecond. Okay, that is that latency is tolerated, and as far as the economic load dispatch, so that comes in a larger time scale, and the mechanical transient time constant, electromechanical time constant, and exclusively electrical time constant, they lie in a different time scale, and associated transient, different control efforts, the transition of the control modes, the action of the different protective devices, and with respect to the certain communication infrastructure and the exchange of the information, how this synchronized measurement plays an important role. That is the point of interest also to get the analysis of the same. This is a very basic, you have the two substation and you have the synchronized measurement from the two, and you have a common type of reference, and correspondingly you are going to avoid the blackout. That means now the question is that now when I talk about the 2012 blackout, have you really analyzed the northern grid, the transmission network, how the blackout and the catastrophic failure occurred in that system, which was root cause of the overloading of a particular transmission system, and what is the root cause of the malfunction of the zone 3 backup, because it is the ultimate line of defense as far as the protection system in the transmission network is concerned. And if the zone 3 got failed, so the catastrophic failure and the cascaded outage that occurred. And in the similar scenario also prevailed in this Mumbai. If you go for a thorough analysis in a particular simulation and you get in a steady state scenario the power flow and subjected to any contingency and any fault, if you introspect the system behavior and you cross-validate that, had the PMU been deployed at the strategic location, this catastrophic failure might have been averted. So that is the point of that is the point of interest to get a comprehensive analysis for the same. So the oscillation mode I have already discussed before, so therefore I don't want to go this in detail because the wide area PSS design I've already discussed. So now I would like to tell you the PMU for the coherency. So first, my first section is for the coherency, how to identify the dynamic, that means online coherency of the integrated power network. So for that, so now you have accomplished the visibility of the grid, that is fine. But when you are taking, try to understand, when you are taking a decisive action as a function of the data, that means it is data driven. So how the data you are getting is really reliable enough. That means you are getting the actual data for the corrective decision to be made. So that has to be done very rigorously because if there is an outlier, if there is a sudden notch, if there is a bad data, if there is a missing of the data, because you are completely dependent upon the decisive action is a function of data driven. It is independent of the integrated model complexity being taken into the consideration. Try to understand. You have a reliable communication infrastructure. You have already relied on the communication infrastructure. That means with the minimum latency and the exchange of the informations, it is not only with the minimum latency you are trying to get, and it is also secured. That means it is just that is another field, that is in the cryptography. That means the message authentication. That means suppose a strategic location, this PMU is there, PMU1, PMU2, PMU3. That means when you are talking to the phase or data concentrator, I am supposed to get a decisive action from the PMU1. So you have to ensure that whatever message being transferred from the PMU1 to the PTC, it should be secure. So that is again another domain. That means the secure message transfer. It is not only the latency and the skewness and the communication bandwidth that you are going to take into the consideration. The secured message information is also indispensable for the same. So the data collection. So when you talk about the data collection, so you just see you have a large scale. You have IEEE. You have a different benchmark system. Starting from your WSS9 bus system, your standard 2-area Prof control model, and you have IEEE 39 bus system. So these are the particular. So you are now in this with the different. That means the optimally PMU being located at the strategic location in order to have a visibility of the grid. After that, you are trying to get the cleanness of the data for the further processing. So that means what it is simple. That means you are, on contrary to the raw data, you are getting the defective data removal, data parceling, outliers. That means just like analogous to the notch. Then the interpolation. That means if you have some missing data, you have to interpolate that. You have to get the exact loci of the pattern of the data. Then you have to filter out some high frequency component and the low frequency component. That means some sluggish response when it is there with respect to the certain time scale. So that means some are redundant informations and some are relevant informations. So accordingly, the low frequency component and the high frequency component should get filtered out. And this is the pre-processed data. That means when you are getting certain features, these are the retrieval of the PMU data for the further analysis. So so these are the stepwise procedure that I told right now to mitigate the corruption, the detail split in the parcel. That without those, so you have the different frames. That means you are splitting it into different frames, and you are visualizing the angle difference. That means you are taking the different signals from the PMU. So, for instance, you are taking this rotor angle, and your different instant of the fault, the faulted voltage and the current respectively, and different other impulsive transient, your certain notch, the possible scenario in the power network, the capacitor switching, like that. So here you are estimating So you are removing the outliers, you are interpolating the same. That means you can perform the linear interpolation, you can perform the cubic spline interpolation. That means based on the correlation between the data. That means it is just like a mutual variable that with the autocorrelation function and the cross correlation function respectively, and the power spectral density as well. So basically, we have taken the two. This was in the Indo-Norway project at that time. It was the PMU signal from the northern power grid and the Nordic grid. So basically, and I told you regarding the function of the high pass filter as well as the low pass filter, just is the control action that for the slow gradual change in the measured signal, which results in the low frequency signal. So they can be attenuated using high pass filter, and the low pass filter, that sampling rate significantly higher than the power system electromechanical dynamics. This is obvious. So you are taking the two PMU signal. One is from the NRPG, that is northern grid, and the Nordic grid as well, with respect to the different frame of reference, that is Agra Hisar and Agra Dadri. You have taken, that means you have the 3 frames. Suppose you are taking the PMU 60 frames per second. Let us take the 3 frames and let us visualize all the relevant data for the subsequent analysis to get accomplished. For instance, you are taking the Agra Hisar and Agra Dadri and with the respective frames F1, F2, and F3 respectively, and you have the angle difference that you are getting in these 3 frames. Okay, and correspondingly, you are also, so this is with respect to, and in the Nordic grid. Now, this is not your point of interest. You are getting some information. It is not your, this is not the focus of my talk. The talk is that how now you are getting how to identify the coherency of the system. That is the fundamental. Just you see this, you start from this normal swing equation. What does it look like? md square delta bt by dt square equals to pm minus pmax sine delta. And if you take the effect of damping, if you have the actual model of the generator with the inclusion of the dampers, and you take the primitive models, so there at the initial instant of some fast swings, you can the effect of damper may get neglected for the same. But now the question is that you have to get the coherency, because now if you take the clubbing of the generators that swing with respect to each other, with respect to a particular frame of reference, and subjected to the excursion, it exhibits the expected response in a unison manner. It may not be possible when you solve this total your second order differential equation it's a non-homogeneous and nonlinear in fact. And not only you have, if you have 2 generators, your aggregation is very simple, but you have a lot of generators being deployed in an integrated power network. So how to get, and it is not only that, at the particular time scale, that samples that you have taken into the consideration at that time, the coherency may get varied. So it is as good as the dynamic coherency. So now what you have done, you have deployed the PMU in optimal location. You have retrieved the data for the subsequent analysis. Now you have get the raw data. Now what? Now you are getting the that means it is as good as a non-stationary signal. You are now interested. So once you get the data, before you get the data, you are bothered about the dynamics of the system. Try to understand, because when we talk something, we talk about the techniques, we talk about the relevant comparative assessment of the figure, improvement, tabular form, not like that, without understanding the basics. Whenever, before the signal being retrieved, even if it is data driven, still then we are going to introspect the behavior of the system. We are full aware of the power net, not only the power network infrastructure, the expected behavior which it is supposed to accomplish subjected to certain excursion. But on contrary, once, on the other hand, when you get the signal, you are least concerned about the network being considered. After that, your signal analysis comes into the picture. whether it is model dependent, data driven, manifestation of the signal from some external source, whatever it comes into the picture, you are least bothered about that. But however, now the dominance in this domain is the introspection of the signal characteristics in an actual exploration of the advanced signal processing. So the non-stationary signal, that means you have the time and frequency. You have to take both the resolution, the time and frequency, in order to introspect the discontinuity of the system. So the empirical mode decomposition, it is just the different monotonic function and the different frequency component being segregated, being splitted, and you get the residue of the same. That means the original signal is a summation of the different frequency component followed by some residue. It is just like a synthesis. You do the normal network, you do the synthesis. Very simple, right? So for that, so now what you are going to get? So when you are getting a transmission network, the unbalanced thing it prevails. But in a distribution network, and particularly in the active distribution network, the sequence component based analysis sometimes become a challenge. But here now you are taking this, you are getting the analysis in the sequence component based and some transformation based. Just you are getting the pseudo voltage phasor angle. That means you are decoupling. You are just decoupling with respect to the path transformation, and you are going for the symmetrical component base for the deviation of the mean voltage, and correspondingly you are getting the total your phasor information and the mean voltage that deviation at a specific boss with respect to the sliding window that you are talking about. So here, so that means what you are talking here, that means it is inherently a stochastic sequence. Why it is a stochastic sequence? Because you have a lot of intermittent source being incorporated, and the inherent stochasticity obviously prevails in the system. So you have the sequence, if you take with the spectral density, and you take this sequence and you get the Fourier transform, and you develop a paredograms, you evaluate the spectral density. So these are all mathematics. I don't want to go in details, but issue is that now you are developed the spectral density, and you have developed this, the stochastic sequence. You evaluate the spectral density, and corresponding to the particular frame in these paredograms, you evaluated the average of that for the spectral density, and you got the spectral coherency. That means you have the non-stationary signal when you are going for this winner value distribution. That means it takes care of the time and frequency resolution in a concatenated manner. And it is a bilinear when it is a bilinear transformation, and contrary to the linear transformation, the resolution comes to a drastically to a considerable up to the expected accuracy, but at the sacrificing the computational burden. So you have to go for a smoothing function so that the computational burden is also reduced, and at the same time the time and frequency resolution is also you are achieving the same. So here, so that means you are getting the instituting mode functions, which is the indicator of the different frequency component of the signal after the retrieval from the PMU is possible. Then you are getting a smoother functions, taking the time and frequency resolution for this non-stationary signal, and you get the corresponding time spectra coefficient and the time varying phase. So the time varying phase is an indicator that this generator is out of phase, or this generator is in the coherent with the particular generator that you are taking into the consideration. So the question here, so what is the concept? So that means the concept is that you have got the raw data from the PMU. So the raw data of the PMU when you got, before that you deployed the in a optimally PMU location in order to have a visibility of the grid. You got the data competent enough for a decisive action. That data was now transferred to the time frequency plane. Then you smoothed it sufficiently to get the time and frequency resolution simultaneously without sacrificing the computational burden for a decisive action to be made. And you got the time varying phase and the time spectra coefficients. So once this is achieved, you can comfortably get the particular generator which is in phase and out of phase respectively. Similarly, as I told you, the Lagrangian normal swing equation dynamics with the inclusion of the dampers. But however, in the fast initial swings, if you neglect that, you can take the total energy as a split of the kinetic energy and the potential energy respectively, and you get the angle-based crack. That means you have a common frame, just like that, because you sometimes, if you read the transformation, you have a local frame of transformation and you have a global frame of transformation. Correspondingly, you project to that global frame of transformation. It is just an analogous phenomenon. The angle-based criteria, it is computed and the Lagrangian function is computed for the same, and correspondingly the relative angle, that means with respect to the total center of inertia that you compute for the integrated power network, where you have taken with a lot of generators, with the other your complexity of the network that do prevails. So correspondingly, you get the relative angle, and you get the potential energy and the kinetic energy respectively by incorporation of the Lagrangian functions. Then you go for the then you can evaluate the trajectory index of the rotor, and you can get also in the Hilbert transform, when you take the function, you took it transfer to an analytic function, and in a complex plane you transfer it, then you get the and it satisfies the Cauchy-Riemann condition, you get the Hilbert transform for the same. So that means what exactly you do, just you see here. This is the mode identification and this is the dynamic coherency. Just you see the just a simple difference here. You are the power system. You have the system model. You go for the eigenvalue. Very simple. That is a model based, right? If you have a model based, you go for the eigenvalue analysis. You go for the sensitivity, participation factor, and the inter-area mode for the frequency. So that means, and evaluate the participation factor of the generator of each modes, and then you excite the exciter and part of the load. That means you do the power network about the operating point. It is slightly being that means you are perturbing about the operating point with the nominal operating point. Then the selection of the oscillatory signals, estimate the frequency, and correspondingly the generators with the higher participation factor and the higher spectral density, that are the coherency. So this is one way. That is one way for the mode identification. But on contrary, when you go for when I take the signal mode and the pre-processing signal, as far as the coherency is concerned, you go for now it is data driven. You are completely have a cleanness of the data competent enough to take a not only the dynamicity of the introspection in a particular sampling period that you are trying to get. You have the instituting mode function, which is the indicator of the separation of the different frequency component, particularly IMF1, which is the high frequency component that retains, and the selection of the IMF with the spectral density having a phase, and often the time frequency correlation function and the time varying, particularly the time varying your spectra and the time varying phase. So this is as good as the both are fundamentally same. Try to understand. But when it is data driven, it is more accurate because you are introspecting. You are introspecting the lot of you are. That means you have already taken a piecewise linear function. Suppose a non-linear function, you are making a piecewise linear, and you ultimately you are just in a just you fundamentally, if you recall the simple definite integral as a discrete sum, right? So correspondingly, if you take this analogous action and we have the different frequency component that do prevails, so you have the different the spectral analysis and with the time frequency control that is being with the 0.25, 0.5, and 0.8 with the different frequency component. This is for the synthetic signal, and for the actual signal that you take into the consideration. So this is for the normal mode-based oscillations as per the inter-area oscillations, and this is the time frequency control and the phase plot. So this I don't want to go in details. Very a lot of things to discuss. So this is your just to see your time varying speed deviation. This is for the generator 7 and generator 20 and the IMF component. That means the once you have got the speed deviation, so correspondingly that signal is transferred to the instituting mode functions. So the IMF component of that exists 0.505 hours, and similarly the time varying speed deviations and the time frequency spectra that you get into the coherency the analysis between the generation 7 and 20, between the 20 and 24, you get. So that means that this generator are coherent enough. That means that with respect to the excursion, they exhibit the speed deviation in a uniform manner. That means it follows a normal trend. And the dynamic varying coherency also with respect to the different case study being carried out and with the actual PMU data with respect to Agra Hisar, Agra Dadri, that is the normal. This is same thing. Whatever you get from the synthetic signal, exhibit the electromagnetic. Just to try to understand whatever your power system dynamics, and with respect to the particular software that you take into the consideration, whether it is a PS card, whether it is a MATLAB, whether it is a electromagnetic transient package, you have a different time scales. You have a slow time scale and in the large time scale. So when you go for the solving of a stiffness of the differential equation with a particular solver, and you get the exact the accurate solution for the same. And when you take the replicate the normal your as a the real system, when you take and you take the corresponding signal, there is some variation due to the different several factors. Several factors means, for instance, you have for instance, you are taking your intelligent relay, your transducer error, your attenuation, phase, amplitudes, your transportation lag. So that is, but that should have a replication of the original system with a tolerable band, right? So that the analysis of the synthetic signal, what you would do, and in the real power network, and correspondingly the network solver is designed accordingly. Thanks to Manitoba, thanks to your all hydrocubic, they have dedicatedly, extensively analyzed the detailed model, starting from the generator, transmission system, transmission line, your different fact devices, all the possible scenario, and the inclusion of the exact dynamics in the network, segregated network has been incorporated. Because sometimes when you neglect for your specific study, but that may be useful for another study. So you cannot ignore that. Thanks to the total research community who are developing this software, we are only using this and you are getting the expected result in that. But really, without taking, just you see, they have introspected the power network nonlinear characteristics in a very in-depth and a comprehensive manner, and with an in-depth understanding for the same. Then for instance, for your coherency study, your certain set of dynamics, certain set of your nonlinearity or other factors, your correlation function of the different generator that you take into the consider, that may be useful. But at the same time, when you are at the faster time scale, your other information is there. So you cannot neglect that when you go for a end product of a software. You have to take all the factors into the consideration to have an exact replication of the nonlinear phenomena of the integrated power network. And again, with the inclusion of the different renewables, with the dominance of the power electronics infrastructure based, when it is going for a low inertia based system, the classical power network, the standards that has already been designed from IEEE, from the EPRI, that is now going again for the thorough revision for that. Because that no more works. For instance, you are talking about the relay coordination, you are for the active distribution network with respect to the bidirectional power flow, your coordination time interval and exchange of the information between the two relays and optimum operating time of the total, your operating time of the relay as far as the relay coordination is concerned, with respect to inclusion of different renewable energy resources, it doesn't work fine as far as the normal conventional way of the relay coordination being carried out. And the standards, the upper limit, lower limits, the tolerable limits, also that is also going in a refined way, and somewhere the grid codes and the standards is not also very in a dedicated manner. It has been implemented, right? So so when we go for that, so that after that we get the critical clearing time and the coherency with respect to the different frame of references. So these are all results. We are going for the, we are not interested for the results. So then you can go for the identification of the different critical set of generators, because your power network is now working at a stressed limit, and unless the critical generator is correctly identified, your stability limit, because ultimately your protection action, your stability, your control, all action, it works neck to neck. So these are all concatenated. So correspondingly, unless the critical generators you get identified the same, the stability in order to interpret the stability of a wide area network, it is very difficult. And now question arises, how to go for the wide area control? You have the different uncertainty in the system. You have the different stochastic source. You go for the different robust control design, subjected to, initially what was there? It was an augmented plant with respect to the plant and controller. But now the question is that communication infrastructure comes into the picture. So the control effort, for instance, you take the state output feedback in a particular framework. You go for the particular, your quadratic inequality, you transfer to the, in a matrix in a linear form. But that is fine when your communication infrastructure is reliable, robust, and absolutely there is no latency. Or even if in a delay you take into the consideration, now another with respect to the communication, dominance of the communication infrastructure, your cyber attack, when it is coming into the picture, your all the limits also it get violated for the same. So that part has to be also taken into the consideration when you go for the robust control design, when you go for the optimal control design, right? So this is for the PMU signal for the coherency as far as the. So similarly, when you go for the fault identification is well documented. You have a lot of you have the starting from the time series analysis and the frequency analysis, and also the time frequency analysis, which was dominantly model based, single-ended method, double-ended methods, and different traveling wave components. your intelligent methods with respect to different your neural network, fuzzy logic, and different. That means and your supervised learning, unsupervised learning. A lot of work has been explored in this direction. But the question is that if there is a simultaneous fault, one fault is not cleared and another fault gets in. So for there, suppose the initiation of the traveling wave and the formation of the Brabant lattice structures, the first arrival time of the traveling wave, it is very difficult if you are concentrating on the high frequency component. Similarly, when you take this simultaneous fault, this time frequency spectra also takes an important role. Just you have analyzed the coherency, and in a similar fashion, this time frequency spectra with respect to the energy based with a particular threshold being selected. Now the question is that how to get the threshold, the adaptive threshold. That is again another area of research with respect to that when you go for the energy based analysis, right? So that means it is as a whole with respect to the particular bus being connected to the different lines, let the indices being evaluated for the same, and correspondingly the simultaneous fault with respect to the power spectral density and the time frequency spectra and the different clusters. It is just like that in the power quality analysis you might be coming across when you project the particular data in the high dimensional space with the minimum separation for the same and achieving the maximum accuracy with minimum overlapping between the two consecutive classes, you formulate a Lagrangian functions with some relaxation of certain variables. That means you convert some unconstrained optimization to a constraint optimization with relaxation of the certain variables in order to achieve the sufficient separation between the two consecutive classes that you talk about. Right. In an analogous manner, when you go for the fault buses identification subjected to the simultaneous fault, the time frequency spectra and the energy based and the clustering with respect to that may capture the similar features clubbed into the particular space with respect to the another clusters. And in this way, you can identify with respect to, and it's just you see your fault resistance, again, you have to dedicatedly model for that. That may also affect the completely, the decisive action to be made for the subsequent protection action to get initiated for the same. So in this way, you have the IEEE 39 bus, IEEE, your others. Apart from the benchmark model, different other models is also being considered, and the simultaneous fault is also evaluated for the same. So this is the schematic, right? So this is the proposed. You have got the phasors. You have estimate the power spectral density, then the nominal frequency, the fault occurred, the pseudo phasors, then the smooth Weber value decomposition for the both the time and frequency resolution respectively, the maximum value, the faulted bus and the parent bus, and the connected bus to the parent bus, and the pseudo phasor. And this, with this, that means this is just a energy based thresholding. You can tell this is as good as a energy based thresholding. Once you get the retrieval of the PMU signal and you perform the analysis with respect to the fault insertion angle, fault resistance, and different case study. Okay. So, and this also, I have also talked about some certain backup protection. So I don't want to again go, because sometimes I told it earlier also, the backup protection, because it is the last line of defense. And when you go for the distance relay, because it is dedicated for the, because you need not have any offset, or that means you should not have any overreach and underreach subjected to any arc or DC offset. So that means your zone 3 operation in presence of the harmonics, the extraction of the fundamental phasor is very straightforward. You go for a half cycle data window, DFT, or a full cycle. Correspondingly, you get with the minimum of the spectral leakage, and you get the fundamental phasor for the same. that is fine. But when there is a dominance of the power electronics converter based source, which is inherently in presence of also the active power filters, also that means inherent interharmonics comes into the system, the fundamental phasor extraction is not a straightforward. So there you go for a different parametric and non-parametric based approach in the signals based and the subspace based with the different frequency selective components that you separate for the same in order to get the pseudo phasors, and you get the as per the PMU standard. That means you are getting the signal from the remote end, and you are getting the fundamental phasor extraction for the decisive action of the distance relay being taken into the consideration as far as the zone 3 backup is considered. So this is for the transmission network. So for the distribution network, also the analogous events comes into the picture, but here it is in the transmission, it is 60 frames per second, it is 120 frames per second, and your transient voltage error, TV, and all in the standard you can see in the micro PMU. You can go for that. It is just like a 3%, 4%. I don't remember for the same. But the events in the distribution system, there are a lot of events, huge data. You have smart meters, you have the different types of loads. You are dominated in a home area network, starting from the refrigerator, starting from your air conditioner, your different frequency sensitive load, your cheap loads, your different hospitals, your critical loads. There the load modeling is another aspect. And your retrieval of the data, for instance, the smart meter, who is getting the 15 minutes data interval. So you are getting a huge data. And your nodes, they are adjacent to each other. The predominance of the resistive component is there. The analysis is not similar as that of the transmission network. So the straightforward, when you go for the neural network based approach or a modular probabilistic neural network or a support vector machine based, these are all that means this is the classical intelligent technique in a transmission network also you come across. But is it really reliable? No, in a distribution network, it is not only the total node that we are talking about. We have a lot of sources. And your distribution network is not in a streamlined manner as far as the augmented infrastructure is concerned. Transmission network is okay. So for that, if you see this hyperplane and this is the Lagrangian function as I was talking about, the formulation of that is with respect to the separation variables and error surface. This is the objective function, bias, error, and the weight function. Multi-objective optimization. And here you go for the deep learning based. That means when you are talking about the redundant features, the relevant features, and correspondingly you get the data for your decisive action to be made. Sometimes the overfitting, underfitting of the weights, draft being the local minima, and whatever bias and you take into the consideration, propagation of the area in the gradient surface, that may be erroneous as far as the different event detection, characterization of the event, classification of the event, localization of the event. Localization, sometimes it relies on the dynamic state estimation. Dynamic state estimation in a weighted least square is straightforward. You go for a process noise and a measurement noise. You evaluate the pseudo inverse. Correspondingly, you evaluate the expectation value, and you get the corresponding whether the ergodicity is there or not based on the expectation value that you take into consideration. But however, and you can correspondingly evaluate the second norm or of that and in a particular zone, whether it is a fault or not. But sometimes the dynamic state estimation, if it is data driven, You are introspecting the nonlinear pattern of the data, and by means of a kernel trick, you are projecting to the higher dimensional space in a linear manner. You see the fundamental. So there, what you are doing. So correspondingly, you are visualizing the linear relationship of the data as far as the state estimation is concerned. On contrary to the standard weighted least square. So there, and once it is done, you have to take the corresponding decision to be made. Similarly, suppose you go for the, on contrary, I told you regarding the overcurrent protection as per the coordination time interval and the total relay operating time. Differential protection is a straightforward when you go for a unit based protection with the reliable communication infrastructure. With respect to the dual slope characteristics, you have the retrieval of the identical, whether you have the current at the two ends and you go for the differential of the same with respect to that, you get the corresponding decisive action in a particular that's zone. It is a very straightforward approach. But on contrary, the settingless, but because you have an active distribution network, sometimes the settingless protection is more accurate. You remember, you have done the economic load dispatch. You have formulated the objective function, both taking the generation demand and the environmental factor aspect, and these two are two contradictory phenomena. And subsequently, you achieved a particular trade-off between these two to achieve a feasible solution. It is just an analogous fact. You have the lot of, you have the speed, you have the temperature, you have the lot of, that means you have the data correlation between that, because sometimes, so that means I am least concerned regarding the rest of the boundary zone, remote end. I'm least concerned regarding the communication infrastructure based on the state estimation and the simple available data at the local end. You are able to perform the settingless protection. Yet to be revealed whether it is working fine or not. And similarly, the control aspect. Control, you have the different layer of the control starting from the primary, secondary, and the tertiary, all you are aware of. And the control effort is also, you have incorporated by means of various available technique that do exist in the literature. But the important is that you have now the cyber layer. You have a physical layer. These DGs, they interact with each other. Apart from tracking a reference, it is exchanging, DG1 is exchanging the information to DG2. And it is now event-based, it is a physical system. So all the control efforts, suppose you take a master echelon control or a centralized control where all the local information is transferred to the centralized control, it is being dominated by the communication infrastructure also. So analogous to the centralized control and the distributed control, the distributed communication network also, because there is a congestion in the communication network. Which communication is important enough to go to have a decisive action for a particular control effort for a particular DG to be taken as a candidate. So this is called consensus based. That means you are taking the consensus of all. It is taking care of the only local information of that DG, and correspondingly, it is taking the consensus of all adjacent agents. And you have the corresponding other infrastructure which is also talking in that particular instant of the time in the event-driven manner. And sometimes when you talk about the robust control, the control effort sometimes have a computational burden, make it event trigger. That means at this time, the uncertainty, inclusion of the uncertainty in the system is remarkable. At that time, let it be event driven. Otherwise, let the controller act in accordance to that. Just like that in a zero order hold, you do just you hold that previous state unless and until the total conversion is complete, right? So you have the dynamic control of the different in the different topological in the consensus based control. It works fine in the both in the grid connected mode, in the islanded mode, and in the different how the total your different DC they interact with each other for the voltage and frequency control, and with respect to the grid connected, islanded, and the transfer of the power also, that taken into the consideration in a tertiary manner. So there you go for the graph theory topology, you evaluate the A's, matrices, Laplacian matrix, the spanning tree, and the consensus tracking error. And correspondingly, the distributed the voltage and the Q sharing and the distributed communication network. That means it is not only going for the consensus-based control in a physical system, the congestion in the communication network and the distributed communication topology is also dominating in this in order to track the reference. So just you see how our total in a distribution network also, how this smart grid aspect, it is also playing an important role like the transmission network. It is equally important. You cannot ignore that. Your microgrid, nanogrid, picogrid. Now, the topological configuration based on the graph theory, that also plays an important role, right? So my question is that, so that means, so these are all different aspects. There are a lot of things that you can go for the extension of the various work. And now the transmission distribution network, no more it is decoupled. It is an integrated framework. The contingency in the transmission network that affects the distribution network as far as the protection, stability, and other aspect you take into the consideration. And so that means initially, on contrary, you are completely your transmission network domain was independently realized, and the distribution network and your total domain was independently realized. But now this is completely decoupled. It is not decoupled. You have the interdependence of the same in order to make a correct decisive action in different aspect that you talk about. So you can go through that. Okay, just because I have to. Okay, so this all I conclude at the same.
So, thank you, sir. Thank you very much, sir, for a very valuable and informative session. Dear participants, if you are having any queries, please ask. Or you can also post in chat box.
And chat, you can directly ask. So because I have very limited time, or otherwise you can send me in the mail. I have to go because Vijay is there or not?
No, sir. Vijay sir is not there, sir.
Okay.
Sir, I think no queries, sir.
Okay, thank you. Huh?
Thank you, sir. Thank you very much, sir.
Thank
Sir,
you, sir.
Vijay
I
sir.
am here, sir. Sir left.
I think sir left, sir. Just now.
Okay. Thank you. So please
Thank
announce
you.
for
Thank
tomorrow's
you.
session.
Yes, sir. Thank you, participants. So tomorrow first session will start from 10 o'clock onwards. So please try to join at least 5 to 10 minutes before starting of this session. Thank you very much.